Good evening, all. So today we are into session number 13, and today we will cover another most important part of EV, that is a battery technology, how the battery works. So over to you, Govindji.
Thank you, Nabangshuji, and good evening and welcome students to this session number 13, where we will be discussing on the most critical part of the electrical vehicle, that is battery. So I'll start sharing my screen. Is my screen viewable, Nabangshuji? If you can just confirm me.
Yeah, it's visible and audible, both.
Thank you very much. So students, in this session number 13, we will be discussing on battery technology. These session we have divided into two parts. Session number 13 and session number 14, we will be covering battery. So today we will do session number 13, and on Monday we will do session number 14. And today also we will have the balance presentations that we were not able to do last Saturday. So when we go ahead with this session, we will be discussing about more about batteries, like what is EV battery, bit of EV battery history we already have done, like in very first session, second session in fact. Then battery parameters and type of EV battery. So we will be covering this session under these four important topics. So what is EV battery? An electrical vehicle battery, also known as a traction battery, is a battery used to power the electrical motors of a battery electrical vehicle or hybrid electrical vehicle. These batteries are usually rechargeable batteries and are typically lithium-ion batteries. These batteries are specifically designed for a high ampere hour or kilowatt hour in capacity. So if we talk about an electrical vehicle, we have discussed about the brain of the electrical vehicle. We have discussed about the structure of the electrical vehicle. Now it comes the thing that powers the electrical vehicle, without which electrical vehicle is not possible at all. So it is the battery technology. So in battery technology, typically if we talk about a battery, if we define a battery in a layman terms, it is a component that stores in energy, okay, and that can be used later. In a battery, with the help of the electricity, you can charge it, and then you can discharge it. The energy can be utilized for doing a process, and again it could be recharged back. So this process of charging and discharging happens in a battery. So this component stores energy for you, which you can use like whenever you require, first of all, and the process could be at the same place where charging and discharging is happening, or the process can be somewhere else, like charging happens somewhere else and discharging happens somewhere else, or during the run also, like you can use the energy that typically you do in case of electrical vehicles. So you get your battery charged somewhere, then you put it in your vehicle, and the same power from the battery you can use it for running your electrical vehicles. So technology for an old technology. It's not very new. It's an old technology.
Not able to hear you, Govindji.
Packs we can carry more power with us. Okay, the charging time is low, and at the same time they are not. They don't require high maintenance. They don't require. So all these factors add to the popularity of lithium-ion batteries. In fact, last 7-8 years they were being tested in laptops and other electronic items, even mobiles and laptops and other electronic items. And from there, this was again visualized, then the same thing was converted into bigger packs, and then we are today with the modern lithium ion battery packs that we are using in the vehicles. In fact, two-wheelers, three-wheelers, four-wheelers, in all sort of vehicles today we are using lithium ion batteries. The chemistry might be that they might be using different chemistries, but the technology is they are using lithium ion as the lithium ion is the core component in all these batteries. So history of EV batteries, this I think we showed also in the second session that we had on the history of the electrical vehicles. So this was how the idea of electrical battery was conceived 100 years, like in the year 1716, exactly 100 years before the electric motorcycle was proposed. So before the battery requirement in the automotive sector was even thought about, the battery technology was first introduced to the world. So these are some of the paper cuttings that we are trying to show you to show like how the technology, the battery was being used to power different type of vehicles at that time. So these were mostly the carriages which were either were to be meant to be uh, powered by animals, like mostly horses. So they were replaced, the horses and the mules were replaced with the battery. So they were like auto driven vehicles were introduced at that time. So they help in automation of these vehicles free from animals, which which increase the reliability of the vehicles also and the performance of the vehicles also. So rechargeable batteries that provided a viable mean for storing electricity on board a vehicle did not come into being until 1859. So battery technology came into being as we spoke about last to last slide, but the rechargeable battery and the battery giving a long-term performance was only available after the year 1859. With the invention of the lead acid battery by French physicist Gaston Plant, an early electric powered two-wheel cycle was put on display in 1867, but it couldn't drive reliably in the street. So this was a testing that was done for the first battery in 1867 by driving a cycle, but that also did not succeed 100%. That was not successful. First practical electrical car was built by Thomas Parker in 1884. As rechargeable batteries are invented, engineers implemented them straight away in electrical vehicles, but weren't successful as the energy density of those batteries were extremely low in comparison to petrol vehicle and could not achieve a satisfactory range. So after rechargeable electrical batteries were introduced, they were first tested and tried in vehicles, but the as the weight of the electrical vehicles is huge, when carrying the passenger, it again multifold. So this test was not that successful, so because their energy density was not that high as it was required, and it was uh, availed by the IC engines. One of the most popular electrical vehicles in that one, it was capable of 0 to 50 miles per hour in 7 seconds. It was extremely high to make it was discontinued. So you can see that very high torque, you achieve the top speed in like in very like less time. But again, the issue that came was that the cost was very high, which we are still witnessing in case of most of the electrical vehicles. But then came the invention of the lithium ion batteries in the late 1900, which completely revolutionized the battery industry. These lithium ion batteries were high density, lightweight, and safe to an extent. So being implemented everywhere from mobile phones, cameras to vehicles, etc. So when lithium ion batteries were introduced in late 1900s, their requirement and their use was restricted to normally most of the electronic items. And since because what we because with lead acid technology, it was not possible to use them in any in any electronic item which we can which we would have which we could carry from one place to another, in fact, because for that we needed a very light batteries pack we needed, so that, and which could store which have a high energy density also, so that we get it charged once, we can move to our destination, we can do our work, and which gives us a like reliability, we can move from one place to another, it is easy to carry. So that of kind of technology everyone was looking for, and this came in the form of lithium ion batteries. So their use in laptops, in mobiles, and in cameras became very popular. So battery parameters: voltage, current, energy density, power density, discharge rate. So these are the most important components if you talk about a battery. So you talk about any battery pack, if you talk about, so voltage level. So normally if you talk about any battery or you talk about any cell, they will give you some voltage rating. They would be rated, the battery or a cell would be rated. Okay, so that rating is normally, we call that a nominal voltage. Okay, nominal voltage of a battery or a nominal voltage of a cell. So what is nominal voltage? So all the calculations, all the conditions that are tested for a battery or a cell would be tested around this nominal voltage only. So it's not so that if a battery or a cell is carrying a nominal voltage, then it would if it get discharged below this level, it won't supply you power or it will stop functioning. It's not so. But what will happen is you can there would be a range available for the operation of the battery, which could be like 10% higher than this nominal voltage and 10% lower than this nominal voltage. So this entire band that we are talking about will be called as the operating range of the battery. So say if I'm talking about a battery which is 48 volt. Okay, so it could the high cutoff voltage could go to 52.4 voltage, and the lower could go to around 42 voltage. Okay, so this would be operating in the range of 42 volt to 52 volt. The battery would be operating. So this would be the operating range, and lower and the higher there would be cutoff from properly cutoff would be mentioned on the way on the battery and the cell. So that would be the nominal voltage. We call it a nominal voltage of the whatever is the voltage that would be the nominal voltage rating of a battery or a cell. Second is the current. So why current rating is like very important, because what current rating would decide is at a particular voltage. Say if we are talking about a nominal voltage, it would be rated for certain current, and as the voltage will keep on going down, if the battery or the cell has to deliver the same amount of power it has to develop or it has to deliver, then the current requirement would keep on going high. So every voltage, every cell or every battery need to have a current cutoff also. So because current going out of the battery or the cell will lead to heat generation in the battery and the cell. So that can cause or can develop a condition where the battery might not like the battery could have repercussions and could develop snags. So there has to be as we said upper voltage level and lower voltage cutoff as we have in the battery. So a current cutoff is also there. So if the current increases from a certain level, from a certain magnitude, normally it is the BMS has a program that it will cut off from the it will stop delivering power to the vehicle. So typically what happens is, say a battery is fully charged, so at that point of time it will have the highest voltage. Okay, so at that time the current requirement would be lower to deliver a certain power. Okay, so the power delivered is normally a multiple of current and voltage. So at the highest fully charged battery, the current requirement would be lower to give a certain power. Now the vehicle is moving, the battery is also discharging. So to give the same amount of power, the current has to increase from the battery. Okay, the voltage keep on going down, the current keeps on increasing. So At the lower voltage range, the current requirement is the highest to deliver the same amount of the power. So both voltage and current would be decided upon, like how much current can flow through the cell, because the current going out of the cell is also directly developing the heat stresses is also it is developing in the battery and the cell. So the current rating is equally important. Normally on a cell, on a battery, they don't give you a current rating, but they give you an age rating. Okay, so that would be a multiplication of voltage, normally the nominal voltage, and uh, multiplication of voltage and current. They would be giving you a particular rating of a battery. So they would be rating the battery in form of age. They rate normally the battery ratings is in age. So the energy density, if we talk about it, is the amount of energy stored in a given system or region of space per unit volume of mass. So typically, if we say, if we compare our modern lithium ion batteries, if you compare with the lead acid batteries, you will find that the same amount of, for same amount of Ah or a kilowatt hour energy of a lead acid battery, we can get the same amount from 1/3 of weight from a normal lithium ion battery. Okay, so that energy density in lithium ion batteries is much higher when you compare it with lead acid batteries. Okay, because at the end of the day, we are also trying to have some technology where we can the energy density is higher. How energy density helps? It reduces the size of the component, it reduces the size of the battery, it reduces, and at the same time also the weight of the battery also comes down if we have a high energy density, which is a very beneficial factor associated with the modern lithium ion batteries. Power density, it is the amount of power, time rate of energy per unit volume. Okay, so the power that it would be supplying per unit volume. So as we said, with high power density and energy density, the weight and the volume of that we would need for a certain age or a kilowatt hour storage of energy, that would be much smaller when compared to a low energy density and low power density battery, if we speak about. Discharge rate. It is given by the battery capacity in age divided by the number of hours it takes to charge or discharge of the battery. For example, a battery capacity of 500 age that is theoretically discharged to its cutoff voltage in 20 hours will have a discharge rate of 500 age by 20 age to 25 ampere. So discharge rate, normally in lithium ion batteries, if we talk about, it is given in the terms of C rating. It is given in the terms of C rating. So there are two C ratings for any battery or any cell: the discharge rate and the charging rate. Okay, typically the discharging rate would be much higher, the C rating for discharging would be much higher, and for charging it would be much lower. So what does discharge rate signifies? Discharge rate signifies how much amount of current we can draw from a cell, at what rate we can draw from a cell. So say if we have a cell of, say, if we talk about a normal cell which has a like AH rating of if NMC cell we talk about, so if it has a 2.2 AH of cell, if we talk about any NMC cell, so if say if it is a 2C discharge rating, if it has, so from every cell we can draw a current of 4.4 ampere we can draw at any point of time. And this C rating, as I said, that it is different for discharging and different for charging. And say if we have a 1C charging rate, so while charging we can like push in 2.2 ampere of current we can push in through each cell. So that would be the that would be defined as the C rating or the charging rating, C rating of any battery. So typically this is how we define the C rating. So how does C rating helps us? C rating helps us in defining like the safety parameters. It helps us in defining the safety parameters, like till where at what ampere we can charge a battery or we can discharge a battery safely. Okay, and this is the parameters where it could be done continuously. The C ratings that I call, they also give you some at some other C ratings that we call that they will allow the say if you need some instantaneous power or very high power for a small duration of time, that will also be supplied, but the duration would be in seconds, some seconds. So there could be an abrupt condition where the cell have to give some power. So, but that would be again like for a very short span that would be. And all these factors that we told you, like voltage, current, energy density, power density, discharge rating, this comes with a data sheet of each cell. So that the data sheet might be different for different cells. Depending upon the manufacturer, you get a data sheet for your cell, and where you can compare all these factors. So watt hour, it is the unit of an unit of energy equivalent to 1 watt of power expended for 1 hour of time. So watt hours, normally that energy that would be stored in the battery. Internal resistance is the resistance within the battery, and it is different for charging and discharging. So internal resistance of the cell. So there are typically the inherent internal resistance in a cell which keeps on increasing with time. So as the charging and discharging cycles, more and more charging and discharging cycles are utilized, this 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 internal resistance will keep on increasing. So it is at from certain after certain life of a battery has gone, or some cycles we have utilized, it is always advisable to either like replace the battery, or the life cycle of the battery is done. So that is why it is said, because the internal resistance of the battery has increased. Okay, so cycle life, the capacity of battery reduces over time, and the number of times it can be charged and discharged under specific condition before its capacity falls to 80% of the rated capacity is called cycle life. So normally how we define the life of a battery, we define it in terms of cycles. So you must have heard that there are when we are going for purchasing of a battery, they say that it is for 1500 cycles, it is for 2000 cycles. All those things are rated for a cell and a battery. So what that signifies? That signifies the number of times a battery can be charged or discharged. Okay, so the life of the battery is normally termed in form of cycles. So typically, if you talk about a lead acid battery, it could have like 300-400 cycles. And if you talk about lithium ion batteries, they could start with 700-800 cycles and can go as high as 3000 cycles and more than that also. If you talk about four-wheelers, the life cycle is much higher than the have more cycles. So this 80% that we are talking about, so as we discussed above, internal resistance we discussed about. So when the capacity falls to 80% of the rated capacity, it means the internal resistance we start utilizing only 80% of the rated power of the battery. Okay, so at that time we say that yes, it has lost mostly it has lost its life, and it is time to replace the battery. State of charge, an expression of the present battery capacity as a percentage of maximum capacity, it is calculated by the BMS. So state of charge, like at any instant, how much charge or what is the voltage of my battery, overall battery, if I talk about, that is called as the state of charge, or SOC that we call. So it is an instantaneous term. If you are moving in a vehicle, this will keep on increasing. It's a dynamic term. So maybe if your vehicle is stationary for a very long time, then also because of some internal resistances, this would change. This would sufficiently, this might fall. Okay, so this is a state of charge is a dynamic component, like a dynamic feature, and it gives you the present state of how much voltage is the battery voltage it shows you. So type of EV batteries. Type of EV batteries, normally these are typically the old batteries that are shown here. These batteries that you could see are the lead acid batteries. So when when EV revolution started picking up, say 90s, when the vehicles started coming and plying on the roads, mostly the two-wheelers, even the three-wheelers and the four-wheelers, all of them, they were using the lead acid batteries only they were using. Still, if you see the three-wheelers or the e-rickshaws that we call, majority of them, they are still using lead acid batteries, because the upfront cost is low in case of lead acid battery. So what battery which will be available to you at 12,000 rupees, the same for same capacity of lithium ion batteries, you would be needing the cost would be around 37 to 40,000 the cost would be. Okay, so instead of like giving an upfront cost, they prefer going for lead acid batteries, which is one third, like 3 times cheaper than the lithium ion batteries. So what happens when electrical two-wheelers were introduced, like in the early 2000 or the late 19th century, when it was 20th century, when it was introduced on the road, they were using this lead acid batteries only. But due to their heavy weight and their high maintenance, and at the same time this because in two wheelers, the if you talk about the space, it is very limited. In three wheelers, in four wheelers you can adjust as you wish, but in two wheelers it is very limited. Okay, so for giving for a particular range of a vehicle, say 30 or 40 kilometers, we would definitely expect from a two wheeler. So in that case, when we were using this lead acid batteries, when we were using, that was not able to give us that kind of range. First of all, that was not able to give us. At the same time, it was much bulkier. So in any case, the majority or the 20 or to 30% of the vehicle range was because was just wasted because of the dead weight of the battery, and then they have to be replaced every year. Thirdly, fourthly, the biggest challenge that vehicle was facing was that uh, when the discharging happens, and this the electrolyte normally heats up in case of lead acid batteries, and due to which the battery tends to inflate. Okay, so because of that, it used to get stuck into the battery boxes that were provided, very present battery boxes that were provided. So that was also causing these issues. So because of all these things, the two wheelers were not able to become that popular because of these restrictions and limitations. But at the same time, in three wheelers, in the e-rickshaws, it was very popular because they have like ample of space where they could be properly fitted, and the weight was also not that big an issue as it was in the two wheelers. So further, going further, then more research was being done on battery technology, which was like less heavy, and which charging time was high. In case of lead acid battery and lithium ion battery, the charging time was low. So the entire industry was looking for something, technology which was like in volume wise lesser, which would the weight also was less, and at the same time the charging time was less. So that kind of technology where they were looking for, which they got in terms of lithium ion batteries. So classification: batteries, the chemical or the physical energy. So chemical, if you talk about, normally all the batteries, the charging and the discharging happens due to because of chemical reactions only. So primary, secondary, and other. Further, chemical batteries were described into primary, secondary, and other. So primary: carbon, zinc, dry cell, lithium, mercury oxide, silver oxide, or the with primary batteries were using this kind of cathodes they were using. In secondary battery, if we talk about, they were using lead acid, flooded or sealed, nickel, cadmium, lithium, secondary. Others, fuel cells. Okay, and physical energy, if you talk about, solar cells, thermal, nuclear energy. So in physical energy, what was happening? Because of some source, what we were trying to do is we were like naturally storing energy in other form. We were converting it into some other form, and then we were utilizing when it was needed. Mostly, if we give an example of like solar cell, solar thermal technology, if you talk about, where water is heated to a certain temperature, and with that heat, either a turbine is run to generate electricity. So in that way, the energy was stored. So they were natural form of storage of batteries. Otherwise, mostly all batteries were in the like were of chemical type only. So primary battery, if you talk about, they are irreversible. That is, once they get discharged, they cannot be charging. In the dry cells that we normally see, the cells that we use for watches, or the clocks or other like toys in other applications that we use, those are primary cells. So they have a like one time reaction only they have. So your ions move from your cathode to anode. Now you cannot like reverse it. Now it would be termed that your battery life is over. Now you have to replace the battery. So that is case with the primary batteries. So internal resistance is very high. They have a short lifetime, easily used. They are smaller in size. They are made up of dry cells, and they are cheaper, used in small devices like a torch and other portable appliances. So we all have seen like the most primary batteries, because they have a lot of use in our day-to-day several appliances that we use in our day-to-day life. They have a huge application. Secondary battery, if you talk about, they are normally the batteries that can be recharged. Okay, so they are reversible and can be easily charged by an electrical supply. So if you apply a potential difference, the ions which have moved from cathode to anode can be through application of voltage can be brought back to cathode, and their state can be reversed. So discharging and charging both can be done. Okay, so that kind of batteries would be called as secondary batteries. So internal resistance is low normally in case of secondary battery, which increases definitely with the increase in the life of the battery. But due to this feature only, they could be same time they could be can be charged back. They are durable. In comparison to primary cells, they are difficult to handle. So difficult to handle in a sense, like it could be said because they are bulkier in the size, and they could be like when you are when you are connecting them to the appliances, that could be the connections might need some extra effort that might need. Otherwise, they are definitely they are used in various other appliances. But when you are connecting them to the load, they have to be properly done with a bit of care. They are larger in size. Yes, definitely they are larger in size. They are made up of wet cells and molten salts. So this is normally the batteries that we are also using today. They are also like not dry batteries, but they definitely need liquid which forms the electrolyte. They are expensive compared to primary batteries used in large devices like inverters and automobiles. So they have the application is different when you talk about the secondary batteries. So in secondary batteries, now we are talking about the lead acid battery. So it is a typical everyday battery used in gasoline car, lawn movers, etc. These batteries are composed of absorbent glass mat that are placed between the plates that absorb electrodes and sulfuric acid. It is of poor performance when used in electrical wheels and outdated. So if lead acid battery if used, so still the largest source or the source of energy storage, if we talk about today also, if we leave out the EV sector, then it is a lead acid batteries only that we are using. So they have variety of use they have. So even for the initial starting of alternators, generators, we use lead acid batteries, and then in all the vehicles for secondary power, for powering the auxiliary, and then for self start, for that we use lead acid batteries. In inverters also, still in inverters we are using lead acid batteries only. And like in railways or where we have to maintain, like we have to keep the relays charged, there also as a as a power backup we are using lead acid battery. So still lead acid batteries are the if you talk in the energy storage industry, they have the biggest share. Still they have the biggest. Now with like time and with improvement in the technology and like acceptance of lithium ion batteries, the use has been started. But still leaving out electrical vehicles, that other for other energy storage purposes, their use is very limited. Mostly in the industry we use lead acid battery. So the feature that separates like other batteries from a lead acid batteries, the biggest advantage that we have with lead acid batteries, definitely first of all, they are like cheaper in cost. Secondly, they have like high charging time and they have low life, but the biggest advantage with them is that they are very efficiently they could be recycled. So if you talk about a normal lead acid battery, we can the main component, the lead, that can be recycled, and we can reclaim up to 65 to 70% of the lead we can reclaim. So you can imagine with two batteries we can again assemble, and we can make another, we can make one new battery, we can definitely we can make. So and this recycling that we are talking about is again very not very sophisticated process, it can be easily done. So we have a like line of small workshops or small factories who are doing this work. Okay, so they are reclaiming lead, and they are sending it to the battery OEMs who are again recycling and who are again using it for making a new battery. Okay, so in this battery, if we talk about that, they are composed of absorbent glass mats that are placed between the, so anode and cathode, if we talk about, they are placed between the plates that absorb electrodes and sulfuric acid. Okay, so uh, it contains sulfuric acid, and at the same time to maintain, and you have to pour in, you have to, from time to time you have to put in distilled water into it. It is of poor performance when using electrical vehicles and outdated. But in, as we have discussed earlier, that in case of electrical vehicles, its use was limited because of its higher volume and higher weight. Then nickel cadmium battery, NiCd, if you talk about, it is one of the most rugged and enduring batteries. It is a high discharge rate, it has a low energy density, and contains toxic metals. It contains. This is again format of the battery which started being used, but it could not become very popular. Then nickel metal hydride, it is the replacement of nickel cadmium. So cadmium, if you talk about, it is again a rare element. So then it was like bettered with the help of the new technology, that was nickel metal hydride. So it is the replacement of nickel cadmium, having mild toxic metals, 40% better energy density, and it is used for medical instruments, hybrid cars, etc. So before the coming of the lithium ion batteries, this lithium metal hydride were mostly used in the for as the power backups for some sophisticated instruments, like the medical instruments you can talk about. Even in their use was there in the hybrid cars also, but they did not become very popular, or their use was very limited. Now talk about the lithium ion batteries. So a lithium ion battery or lithium ion battery is a type of rechargeable battery. Here lithium ion moves from the negative electrode through an electrolyte to the positive electrode during discharge and back when charging. So lithium ion batteries use an intercalculated lithium compound as the material as the positive electrode, and typically graphite as the negative electrode. These cells are the highest energy density cells currently on the market, and they themselves come in various different chemistries. So now we have studied, initially we have studied the type of the technologies that started being used for energy storage. And now the latest technology that we talk about is the lithium ion batteries that are mostly being used not only in the electronic appliances, but also their use is very popular in the EV. So if you talk about as the normal battery structure, if as you talk about, they also have an anode and a cathode. So depending upon the chemistry, the cathode is made up of which definitely will have like lithium as a primary component it would have, and the anode, that the negatively charged anode, that is made up of, normally that is made up of graphite. Okay, so in during the charging discharging, what happens is this lithium at cathode, this lithium ion is broken up, and it this free lithium ion moves to the anode, and at the same time a free electron is released, which move in the circuit in the form of the and the electricity is generated in the opposite direction of the movement of the electron. So when the battery gets fully discharged, this the entire lithium ion moves from cathode to anode and accumulates at anode. So that condition of the battery, we will call it as fully discharged. Now to charge it, we will again apply an external voltage, with the help of which we will try to move this lithium ion which has accumulated at the anode. We will try to we will, with the help of the potential difference applied, we will try to help it and will try to move it back to the cathode, so that the position and the condition of the battery will be again reclaimed, and it would be called as a fully charged battery. Okay, so this is a charging cycle and a discharging cycle. Lithium ion batteries use an intercalculated lithium compound. So the two very like popular chemistries that are being used are like NMC. NMC was the very beginning chemistry in which the lithium ion cells started being available in the market. And now, if you talk about, now we have LFP that is more widely used. So if I talk about NMC, it is nickel, manganese, cobalt. And if at LFP, if you talk about, this is lithium ferrite phosphate. So in the case of if you talk about NMC chemistry, if we talk about, what happened was that it was the initial technology, and it has some like inherent disadvantages it has. So it was affecting, like it was thermal, it was developing thermal stresses, and because of which the batteries were catching fire, and it contained more rare elements it contains. So this technology was bettered with the help of LFP. And NMC has a limitation that the cells were available only in one format, cylindrical format, and it was because of its high energy density. They were they were available in a like very low capacity only. They were not like developed into higher capacity cells. They were not developed into. But in case of LFP, like the same cylindrical cells were again like available in the form of were developed in the form of prismatic cells also, and the pouch cells also, to deliver to make available to the variety of use. So if it is small cylindrical cells, then you can imagine that if you want to assemble a battery for a four-wheelers, it would take the cells would be the cells that you will require would be in thousands. So in LFP, this cells are available in prismatic forms, which has like higher single cell will have higher and energy. They would store more energy, so that you have to handle lesser number of cells. So this present technology, if you talk about, mostly the batteries that are available are the LFP chemistries. So working principle, if you talk about a battery, is made up of an anode, cathode, separator, electrolyte, and two current collectors, positive and negative. So as we know that in every battery we have anode, we have cathode, and we have electrolyte. Okay, so in discharging, the ions will move from cathode to anode, and in charging, the collected ions we bring back to the cathode from anode. Okay, so anode and cathode store the lithium. The electrolyte carries positively charged lithium ions from the anode to the cathode, and vice versa through the separator. So here, in case of lithium ion batteries, if we talk about, we have a additional thing called separator. Why we use separator? Normally the separator used because with the passing time, these the lithium ion tends to form to develop tentacles. So what tentacles typically do is they can like with time being, they can short the anode and the cathode. Okay, so the separator is there so that these tentacles does not grow and does not move, does not exchange their side. So they are restricted to one side only. Because if they they move from if they develop to that extent that they could short the anode and the cathode, because the difference between like both is very less, and if that happens, then that could bring down the life of the battery to a considerable level. So the anode and cathode store the lithium. The electrolyte carries positively charged lithium from the anode to the cathode, and vice versa through the separator. So the both processes of charging and discharging take place. The movement of the lithium ion creates free electrons in the anode. which creates a charge at the positive current collector. The electric current then flows from the current collector through device being powered to the negative current collector. The separator blocks the flow of electrons inside the batteries. So as we said that this separator is mostly used so that this the flow of the electrons doesn't occur, and at the same time this tentacles that has developed, these lithium ions have developed, that doesn't allow the both the anode and the cathode to short circuit. So that is the mostly the use of the separator. Now comparatively, a comparative study, if we talk about lithium ion batteries and lead acid batteries, if we talk about, so it cool down time period, it refers to the time period of battery where the battery cools down after being used for a certain time. And opportunity charge, it refers to the practice of charging an industrial battery for a short period of time throughout the day as opposed to charging it in full at once. So these are the two basic features that a battery has. So cool down period and opportunity charge. So charging time, if you talk about in lead acid battery, it is 8 hours. In lithium ion battery, it could be as low as 1 to 2 hours only. Cool down period, so 8 hours, and in lithium ion it is not needed because mostly because it is liquid free, and the heat developed that it dissipates very fast. So cooling down is normally, this is not applicable for normal lithium ion batteries. Charging method, removed from forklift, placed in charging base and taken to special charging storage room. If you talk about the lead acid battery, definitely they can be charged in the vehicle itself, but then also the charger is also very bulky, which has to be maintained in the proper maintained at a proper place. But if you talk about lithium ion batteries, plug directly into the wall when even while the battery is installed in the forklift. So you don't need to battery and charge it. Both can be done. It could be a removable battery where you could remove it and you can charge it, and at the same time it can be charged while it is still installed in the vehicle itself. Safe discharge, down to 30 to 50% capacity, down to 20% capacity. So safe discharge in a sense that you can extract more power out of it. So the depth of discharge, if you talk about, is much higher in case of lithium ion batteries. You can like from the nominal voltage, you can the bandwidth that we spoke about is much larger in case of lithium ion batteries when compared to lead acid batteries. And opportunity charge, there is no opportunity charge, and in lithium ion, yes, it is available. Again, some comparison, if we talk about the nickel cadmium battery that we have spoken about, nickel hydride battery that we have spoken about, C lead acid battery, and then lithium ion battery. So in case of anode, in first case it is cadmium, hydrogen alloy. In case of nickel metal hydride, lead, and then carbon graphite. Cathode, if you talk about, this is nickel oxyhydride, and lead dioxide in case of lead acid battery. And lithium ion, if you talk about, the cathode can be dependent upon the chemistry. So it is, if it is NMC, then it would be like a compound of lithium, nickel, manganese, and cobalt. And if it is LFP, then it would be LiFePO4. That is lithium, ferrite, and phosphate compound. Voltage, this again nominal voltage that we are talking about, it would be 1.2 volt in all the batteries. In SL it would be 2 volt, and if you talk about lithium ion batteries, it could be like 3.2 volt to 3.7 volt. In case of LFP batteries, if you talk about the nominal voltage is a bit lower in case of LFP batteries, and it is higher in case of NMC batteries. So energy density medium, low in case of lithium ion, and very high in case of lead acid. It is low, and in case of lithium ion, it is high. Cycle life, if you talk about in nickel cadmium, cycle life is high. In case of nickel metal hydride, it is medium. Lead acid, it is low, and in case of lithium ion, if you talk about, it is high. And again, to give you like a small information, that in the cycle life of LFP is much higher in comparison to NMC. So memory effect retains A smaller capacity, yes, yes, no, no. So if you talk about memory effect, like what does a memory effect means that, say if our battery is discharged, fully discharged, and now again if we are again recharging it, then what happens is the entire ions that have collected at the anode will move back to the cathode. Okay, so if has some like memory effect, then all the lithium ion, not just lithium ion, but any the positive ions that have moved to the anode will not move back to the cathode. They will leave some impression behind on the anode itself. So in this case, what will happen? The ions will keep on collecting and the potential difference will keep on falling between the anode and the cathode, even during the fully charged status. So in case of nickel cadmium, nickel metal hydride, and this is this effect is available, but in case of lead acid and lithium ion batteries, this effect is not there. So you can fully reclaim or fully move the all the positive ions, you can move charging cycle. Maintenance upkeep, it is high in all three type of initial three type of batteries, but it is very low in case of lithium ion batteries, because it is totally dry. It doesn't need any type of liquid or anything. So the maintenance is very low. Environmental concerns, if you talk about, high in case of nickel cadmium, because they are using some toxic elements they are using. Nickel metal hydride, it is very low. Very high due to lead. So in lead acid batteries, it is very high due to lead, but mostly since it is recyclable, so effect on the environment is limited. So if you talk about a normal battery, if we can reclaim 65% of it, so 35% effect, again it would be putting like 30% would be either discharge in some or the other form in the environment, and that would be hazardous to the environment. In lithium ion batteries, if you talk about, it is low. Definitely it is low. And with the, if we can develop the recyclable recycling technology, if we can develop upon, then definitely the impact that it will be putting on the environment which will be much lower than this. Safety concerns, low safety concerns in case of nickel cadmium, nickel metal, and lead acid, if you talk about. But in lithium ion batteries, the safety concerns are very high. Definitely it has been provided with uh, with EMS and other electronic circuit. It has been provided with which always keep a monitoring of the battery for its safety. But then also there could be some conditions which can develop with time, which could turn it into fatal accidents also. So regulations, low, very high due to safety concerns. So lithium ion batteries storage, you need to have proper place, you need to have proper place when you are maintaining the batteries, or whenever you are you are working on the batteries. It has to be done under very like safe condition. It has to be done, the person even who is working on the batteries has to be highly efficient. Otherwise, like that could anything, uh, uh, a small negligence can also lead to a big accidents for lithium ion batteries. So lithium ion battery applications, if you talk about, lithium cobalt oxide, LiCoO2 is the material, abbreviation is LCO. So these are the like different chemistries that we are using in the lithium ion battery. So normally cell phones, laptops, and cameras where we use it. Lithium manganese oxide, LMNO4 or LMO also we call it. It would be used in power tools, EVs, and medical and hobbyists. Lithium iron phosphate, LiFePO4, that I told that I spoke about to you. It's the most latest format of the latest chemistry that is being used in lithium ion batteries. And also it has a, not only it has a like wide use, but it was also termed as more more safer than other formats that are available. So it can be used in power tools, EVs, medical, and hobbyists. At the same time, lithium, nickel, manganese, cobalt oxide, if I talk about LiNiMnCoO2, so it is NMC battery, we call it in general language, we call it NMC battery. It is one of the initial format of lithium ion batteries that was introduced for the EVs. So it can be used in power tools, EVs, medical, and hobbyists. we can use it. And at the same time, to bring to give you an information, like NMC battery, like if you talk about their energy density is much higher in case in when you compare with other available chemistries of lithium ion battery. So you can draw more power out of an NMC battery, because the operating range of NMC battery is much higher. And lithium nickel cobalt aluminum oxide LiNiCoAlO2 NCA, EVs and grid storage. Okay, and lithium titanate, if you talk about Li4Ti5O12 LTO, EVs and grid storage normally they use. So if you talk about all these chemistries, LFP and NMC are most widely used in electrical vehicles per se, if you talk about. So these two chemistries are very widely used, and even now mostly the new vehicles that are coming up, they are coming up with LFP chemistry only. So this is Leon battery demand that has just first of all, till date we have shown some like how much, what is the requirement from the market, and also we are given a forecast like by 2030 how much it will increase. So you can imagine, like from 2015 to 2030, just in 15 years, like where has the demand like gone up, how much the demand has gone up. So most biggest contributor here is the passenger EVs. Second is the commercial EV, stationary, then power storage contributes to the third. Buses are like least contributor, but definitely the numbers are also increasing from every day. The numbers are increasing because in public transport also more and more electrical buses are being introduced. You can also see even in your city also, you would see that more and more government or the transport department is trying to bring in more and more electrical vehicles into their fleet. So we have spoken about lithium ion batteries, and so in what format they are available. So few sessions back someone asked us the question that can the battery could be, we could customize the battery. So still now what we are dependent upon, like we are not in India, if you talk about we are not on commercial basis, we are not manufacturing cells, we are importing cells, and then we are, with the help of those cells and BMS, we are assembling into the batteries. Okay, depending upon how much like energy, how much energy we use it for, depending upon the voltage range and how much energy we would be storing into that. In that way we are assembling the battery. Okay, so so the smallest format that is available to us are the cells, and through them we would be assembling the battery. So these cells could be mostly they are available in the cylindrical format only. NMC, if you talk about, they are available in the cylindrical. Talk about LFP, they are available in the prismatic format, and also in the form of pouch cells also they are available. So in case of NMC chemistry, if you talk about, they are still available in cylindrical format only. So they have a typical they are defined by a certain number. They are defined. So like if you talk about a typical NMC cells, then it, mostly that are available in the market are 18650 cells. So what does 18650 this signifies? The first initial two the two digits, the 18, that signifies the dia of the cell in mm, and the next two digits, that is 65, they signifies the length of the cell, that is 65 mm. So if you see a number on any cylindrical cells, if you see on the number, then the first two digit would be signifying its dia, and the next two digits would be signifying its length of the cell, all in mm, all in mm. So this is how a cell would be identified. So first chemistry, then what are the dimensions of the cell, so this number, then the nominal voltage would be written on that cell, and then the age level, age of that cell would be written on that. So that way we would be identifying a cell. So that is done for the cylindrical cell. If we talk about the prismatic cell, if we talk about, so they are available in the form of the canisters. Okay, So in NMC cell, if you talk about, they are like available in 18650 format also, and in with much bigger volume also they are available. Okay. So that dia would be bigger, and even the length could be more than the normal 18650 cell, and they are also available in the prismatic format. So in prismatic form, they are available in the form of the rectangular sizes. They would be available in the form of the cuboid structure. They would be available. So the nominal voltage will be very much like same as the cylindrical cell, but they would be the H would be higher. So they could, a single cell could be of a 40H cell also, that could be that is also available in the market. So what ease that give you is that instead of handling so many cells, say if you are assembling a battery for a four-wheeler, which would be requiring thousands of cells if you talk about the cylindrical cells. So instead of doing that, you can assemble the same battery with the prismatic cells, and you have to manage lesser. Okay. And if you talk about a battery pack, normally a battery pack, the smallest unit is the cell. The cells are then connected in parallel, okay, to form a module, and then those modules are connected into the series to form a battery pack. So this way a battery pack is formed. Normally we divide it into modules so that the monitoring of the cell is easy by the BMS, and at the same time, if there is an issue with any certain module, then that module can be replaced. Instead of replacing all the cells of the batteries, only a single module can be replaced. So that gives an ease of repairing and saves our cost also. So we have studied today about the basic the history of the cells, batteries, like how lithium ion batteries have evolved, types of the chemistries that are available in the lithium ion batteries, the cell format that are available, the smallest unit of a battery, that is the cell, in different formats that they, in which they are available, and how we can assemble a cell. In next, going ahead in the second, we have one more session related to the battery only on Monday. So there we would be like going into the depth of how we can assemble a battery, and for assembling a battery, how to calculate the number of the cells, and all other things we would be studying over there. So now if anyone has any query related to this session or related to the battery technology, he can put either in the chat box or he can raise his hand.
Good evening, sir.
Yeah, Uday, good evening.
Sir, if the size, capacity of the battery is increasing, then size of the battery is also increasing.
Yeah.
So what is the challenge we are facing to decrease the size and increasing the capacity?
In what sense? Increasing the size and the capacity of the battery, you are saying?
Yes, sir. I mean, I want to build a high capacity, high range of battery with a smaller in size.
Smaller cells.
Challenge? Yes, smaller size.
Okay, smaller size.
What is the challenge we are facing?
See, the biggest challenge is, as we already spoke, the smallest unit that is available with us. Okay, so we can't remold it, we cannot change it, because we only the cells, either they are available in the cylindrical format or they are available in the prismatic format, that is the cuboid format that they are available to us. Okay, so we have to go with those cells only when we are assembling a battery. Okay, so that is a challenge. We cannot change their volume, we cannot do up and down, because the smallest volume that is available to us is in that format only. So we have to accordingly we have to arrange them, and because of which for a particular, say, energy, say kilowatt and a voltage, there would be we can do with very precision also. If we assemble a battery, we will not be able to make much difference in the volume of the battery pack. Okay, because this it is entirely governed by these cells only, okay, which whose volume is fixed, whose dimensions are fixed. So we have to go by them only. So this is the biggest challenge that we have if we want to downsize or we want to constrain the size of the battery. This we are considerably not able to do it. Now, what prismatic cells, they give us an advantage over these cylindrical cells, because when we are arranging the cylindrical cells, there are when we are placing them in the spacers, there is between the four cells there is some space left out. Okay, but with these prismatic cells which are rectangular in size, there we can definitely we can reduce this size. So with the use of prismatic cells, yes, you can reduce the volume that would be required for a particular kilowatt hour and particular voltage of the battery. So there you can do it, but again there are restrictions because of this available format that is there with us. Okay, so because available in only particular formats, we have this restriction.
Yeah. Okay, sir. And one more thing, like lithium-ion batteries are costly, and
Yeah.
lead acid is less in cost.
Yeah.
But due to some like due to some advantages, we are using lithium-ion only.
Yes.
So, like for due to this environmental aspect, and one more thing you have explained, sir. So only for those things, the major difference is only that those things, sir, or any other things.
And see, biggest advantage is with weight, as I spoke about. Say if you are using in a two-wheeler, if you are using a two-wheeler of 48 volt, that is giving you roughly say a range of 50 kilometers. So you are using say uh, uh, 1.5 kilowatt hour battery or 1 kilowatt hour battery if you are using into your two-wheeler. That would be like in weight, if I talk about, that would be like say in certain kgs, 5-6 kgs only, and for the same amount of energy storage and for voltage, if you are using lithium lead acid battery, then that would be 3 times more heavy. Okay, so in any case, like your vehicle range would be affected because you are carrying that weight with you in form of battery. You are carrying dead weight with you, so that would be affecting your range. So because of that, weight becomes very important. Then sizing, as I spoke about, sizing is again important because very limited space is available in the vehicle, mostly in the two-wheeler. Then maintenance, if you talk about lead acid battery, you have to timely schedule maintenance, you have to do it. You have to fill in the distilled water from time to time, which because of like heating effect, it could evaporate, so you have to again fill it. So there you need maintenance. And at the same time, the charging time is very high in case of lead acid battery. It would take 8 to 10 hours to charge, whereas lithium ion batteries would be charging in 3 to 4 hours. That is a very big advantage in case of EVs. Okay, and as I spoke about, and this maintenance free, it is maintenance free. So these are the factors which make lithium ion batteries like more like user friendly, and which makes them more popular. At the same time, this operating range that we spoke about, like from the nominal voltage, this is band is much higher in case of lead acid lithium ion battery. So their energy density is high, you can extract more power from them.
Yeah, yes, sir. And one more dot, like, sir, can you explain again this energy density and power density?
So energy density is like per unit area, how much energy you can store. Okay, so as we spoke about, a single cell of a lithium ion battery, if you talk about cylindrical cell 18650, that would have 2.2 energy you can store into that. Okay, so if you talk about lead acid battery, that would be taking you have seen a normal small cylindrical cell and a small battery that we use normally in the bikes that we use. If you compare them, then they would be like two cells at a time and the same battery. The energy would be same stored in both the batteries. Okay, but you can imagine how much area it is taking and how much area it is taking. So in that case, energy density is the energy that can be stored per unit area. Okay, so more energy can be stored in a smaller area in case of lithium ion batteries, And like if you talk about other technology, they would be requiring more area to store that energy. Okay.
Yes, sir. And power density?
Power density is the how much power you can store in a particular volume. Okay, this area we spoke about in per unit area, and this is per unit volume, how much power you can store. So
Yeah.
that's
Okay,
power
sir.
density.
Got it, sir. Thank you.
Good evening, sir.
Yeah, Lakan, hi.
Sir, what are solid state batteries, sir? Can you explain?
Solid state batteries are the batteries which does not require a electrolyte, liquid form electrolyte, which does not require. So the fuel cells that we are talking about, those would be like solid state batteries.
Fuel cells, sir.
Normally the batteries that we are using in our day-to-day life today, you talk about lead acid batteries or lithium ion batteries, these are not these are like liquid state batteries only, because they are using liquid electrolyte they are using.
Okay, sir. Sir, about the fuel cells, sir.
Yeah, can you speak a bit louder? Your voice is not clear.
About fuel cells, sir. Fuel cells.
Like, so fuel cells, like we spoke, the hydrogen cell is one kind of a fuel cell, and like other technology that we are working on still in the research stage. So those will all be will be categorized under fuel cells. So wherever the electrolyte is not in liquid, those are solid state batteries.
Okay.
So Dinesh,
Got it, sir.
Dinesh Reddy is you have like you want to ask something else also, Lakhan?
No, sir. No, sir. Thank you.
So Dinesh Reddy has asked a question, sir. What is the lifetime for lithium-ion battery, and can we recycle lithium-ion batteries? Like Dinesh, like normally the lifetime of lithium-ion batteries, we term them in the form of the cycles, the charging and the discharging cycle. So typically, if you talk about NMC battery, then their life is ranging from 800 to 1200 cycles. So they could be charged and discharged for 1200 cycles. They could be charged and discharged simultaneously. So say you are every day, if you are fully discharging it, and again in the night you are fully charging it, so you can do it for 1200 days, you can do it. So that would be roughly say 3.5 years or something. Okay, so it would be defined in form of the cycles. And if you talk about lithium ion battery, yes, they can be definitely recycled, but the process is complicated. So if you talk about talk of a lithium ion batteries, it contains the most several rare elements it contains, lithium being one of them, most primary lithium. So while when we are recycling it, our aim would be to reclaim lithium ion. So element in form of element. So if it comes to so to get that in the form of element, pure lithium element format, if you want to get, the recycling process is quite complicated. Still, if you talk about globally, there is no as such like commercially functional recycling facility is there. In few years back in Switzerland, they have established it, but still they are also not getting that much raw material to recycle it. But okay, so until and unless this much raw material is available, and we are we are ready with some technology through which we can recycle it efficiently, we can get the lithium in form of pure element format, and that could be done with a lesser cost if we can do it efficiently, if it economically efficiently, if we can do it. So that way we can recycle it, but still the technology is still in nascent stage. Very efficient technology of recycling lithium has not developed as of now. Yes, Dinesh. Hello. So typically in recycling, what we are doing, if you talk about lead acid batteries, we are trying to reclaim lead. Okay, so in lead acid battery, it is very simple. The lead can be reclaimed to 65%. We can reclaim it from a battery through a very a very basic process. We can do it. But in case of lithium ion battery, it is complicated. Now several companies are claiming that they are recycling lithium ion batteries, but what they are doing, they are extracting lithium in compound format. So that could be a compound of say cobalt lithium, or NMC battery if you talk about, so cobalt lithium or nickel compounds could be there. So what they would be do, they will not get the pure lithium, but they will get a compound which they could supply to other industries for their use, mostly to the fertilizer companies. So that is the kind of recycling that is being done. So if someone says that they are recycling it, you ask them whether you are like able to get the lithium in element format, or you are reclaiming in the form of a compound.
Okay, thank you.
Yes, Dinesh, you have something else to,
No,
something
sir. No,
more
sir.
to
Thank
ask?
you, sir.
Thank you.
Yes.
Other students, if anyone has any query, because this is like very important topic that we are discussing. So the vehicle at one side and your battery at one side, both are like equal. As we have earlier also spoken, 40% cost of an EV is a battery. Okay, so battery is equally important as are all other components of a vehicle taken together. So if you have any sort of query, please ask. I was expecting a lot of queries today because we were like into this very important topic. So I thought that there would be a lot of queries on this. If you're not able to unmute and ask, then you can even post it in the chat box also, not an issue. Students, we will wait only for another 5 minutes. Then we will have to
Yes,
take.
sir. Yes, sir. Like of next session is going to start by 6:15 onwards, sir.
Yeah. So all students request you again, if you have any queries, please ask.
Sir, we'll just closing the session, sir, and the next section is going to start by 6:15, sir.
Okay, we do that in that case, since like students are not asking any query. I think they don't have any query. So like this session we close it, and we meet again at 6:15. And students today who are lined up for their presentations, to
Yes, sir.
be ready with their presentations.
Yes, sir. Everyone is ready, sir. Almost 4 presentation is there. First presentation for the idea about the case study, and
Yeah.
next, 3 presentation for presentation part.
Okay, not an issue. Okay, so then
Yes.
at 6:15, like we
Yes, sir. We will
meet at
get back.
6:15 in that case.
Guys, okay. So yeah, students, for everyone, okay. So please kindly join by 6:15 onwards, okay.
Thank you, students. We come back and we again connect at 6:15 in that case. Okay. Thank you very much. Thank you.
Thank you, sir. Thank you, sir.
Thank you.